Thanks everyone for coming. My name is Trent Blackburn. I'm with AWS Managed Services. My pronouns are he, him, and I am a systems engineer with the AMS team. And today we're going to be talking about how AMS uses PowerShell. There's a lot going on in that space. But first we'll kick off with some introduction. So a little bit about myself. This is going on my 6th year at AWS. I started out as a cloud support engineer for about 3 years, and since then I moved to the AWS Managed Services team as a systems engineer. And before that, like a lot of folks here I know, started out as a help desk technician and became a systems administrator. When I am not working, I am a big sports fan. I follow the Washington sports teams, Washington, D.C. Not this Washington. I know it's the wrong one, but you know we can have those fights afterwards. And when I'm not watching sports, I'm a big electronic dance music fan. So I actually just came from a music event right before I flew here. So that was a lot of fun. So that's what I like to do in my spare time. So the agenda today, I'm going to go through a little bit about what AWS Managed Services is, what we do, what the team is all about. Going to go at a high level how AMS uses PowerShell and a lot of the day-to-day things that happens at AMS. And then we're going to dive into some code examples as well, and I'm going to walk you through those step by step, and we're going to talk about how they work, how they flow, how they orchestrate, and all of those different things like that. So, first, what is AWS Managed Services? Show of hands, has anybody here heard of AWS Managed Services? I hope all of my AMS colleagues and AWS colleagues have heard, but I'm glad to see some other hands went up, so that's awesome. I'm glad you guys know about it. For those that don't, AMS helps AWS customers operate AWS infrastructure. So it's a collaborative effort, it's a team effort, and so we allow AWS customers to work with us in order to make everybody's lives better. As cheesy as that might sound, that's the mission statement really. We leverage AWS services as well as our own in-house automations to orchestrate everything. So think best practices, think infrastructure provisioning, think all sorts of different things that a lot of different companies and people have learned over the years with infrastructure in general and with AWS infrastructure as well. In terms of just making everything easier, more secure, operating better, cost optimization, all those types of things is a lot of what AMS does as a value add. And we do that in part through a lot of detective and preventative controls. So try to figure out when things are going wrong and ideally alert on those types of things. And where possible, we try to prevent things from going wrong in the first place with different things like IAM security policies and things like that to make sure that different users have permissions to only the things that they need. Or for example, when a instance is running its CPU out of control, we like to alert on that as well. So those are just some broad examples of what AMS does. And as kind of a little bit of a background, AMS is ideal for both new and existing AWS customers. So we've helped a lot of customers migrate to the AWS cloud, and some customers have gone on to manage those migrations after the fact on their own. They manage their infrastructure day to day without AMS. Some customers like to migrate into AMS and utilize our knowledge and skill set and engineers to help them operate day to day. So it's a little bit of everything there. So as far as how AMS uses PowerShell though, there is a really broad range. So AMS doesn't specialize in Windows. It's Linux and Windows across the board. So pretty much just about most of the broadly used operating systems AMS supports in some way. And so with PowerShell, you can imagine for the full life cycle of any Windows infrastructure. So one big thing we do is bootstrapping, and that takes care of things like setting up some agents and code that AMS uses for monitoring, alerting, and different things like that, as well as joining domains, making sure that the right domain membership is maintained. If it ever fails, if the trust relationship ever fails, I'm sure a lot of the Windows folks have seen that happen, try to correct that, or at least alarm alert on it and things like that. And then, like I alluded to, monitoring as well. So we like to monitor CPU, memory, disk utilization, different things like that, all of those types of metrics and things that most folks are used to at least knowing. Anything that you could see in like a task manager, for example, is stuff that we like to monitor at scale and alert on and alarm on. So we can use PowerShell a lot to work with that as well. And leading into, nicely, remediation of some of those issues. So for example, if a trust relationship in a domain fails, there's some PowerShell commandlets that I'm sure some of you have run before that can help to repair that trust relationship. Sometimes it works, sometimes it doesn't. It's not going to say that there's any type of silver bullet, but try and reduce some of that operational load that your team would normally have to do from an operational standpoint. One of the big pillars of AMS is reducing what's called undifferentiated heavy lifting. So everybody has to patch, everybody has to monitor, everybody has to alarm, alert, everybody has to manage and configure infrastructure, and nobody really likes doing that. You want to focus on what your business actually provides to your customers. So that's a lot of what AMS does in a nutshell. And also we do a lot of work with change requests in general. AMS does that as well as just change requests specific to Windows. So imagine trying to launch any sort of AWS infrastructure. We use PowerShell to configure that, and we use PowerShell where possible to have ongoing monitoring and different things like that. And the two big services that we use in AMS specific to PowerShell are Systems Manager and CloudFormation. So let's have a show of hands. Who has used CloudFormation before? Okay, that's nearly everyone. That is great. What about Systems Manager? That's about the same number of hands, so that's awesome. Okay, so you guys are pretty familiar with what those are. For the couple hands that didn't go up, CloudFormation is AWS's infrastructure as code. And it's exactly what it sounds like. It's just developing and maintaining infrastructure in code format rather than anything that you would be used to doing in the past, like spinning up infrastructure and maintaining it by hand. So it was the old, in the previous presentation, it's pets versus cattle, if you've heard that metaphor before. And Systems Manager is something that we'll get into here in the next slide a little bit. And so at a super high level, don't really need to go into too much about what Systems Manager does since it's not an AWS specific talk, but since most of you are familiar with it, we'll just do a quick version. It's meant to help operators and administrators view and control AWS infrastructure. So you can have a single pane of glass in order to see all of your instances and different things like that. It's for all different types of infrastructure, but we're going to be focusing on Windows Windows in this case. It is agent-based, so Systems Manager, a long time back, used to be called SSM, used to be called Simple Systems Management. If some of you have used Systems Manager for long enough, you may recognize that name. It's been rebranded a few times. Systems Manager is what it goes by now. And then basically all AWS images have that agent baked in. And can also be installed on-premise as well, which is pretty cool. So you can kind of have a hybrid approach if you have some on-premises infrastructure or multi-cloud as well. And the biggest point about that agent is that it enables us to run PowerShell code. It enables us to do a lot of other things as well, collect inventory and everything like that. Since you guys are familiar with Systems Manager, I won't go into too much about that, but the really important part is that it helps us run any arbitrary PowerShell code we want, particularly at scale. So the SSM agent communicates constantly back with AWS backend infrastructure, and that allows us to push arbitrary code to it through AWS, through the console, through CLI, through any different way that you might want to do that. And we can do a lot of that in an automated fashion so that we don't have to have operators doing that on a manual basis. So that is the big takeaway here, that we can run whatever PowerShell code we want on Windows VMs at scale. So a few examples that we have to go through. Don't know how quickly I'm going to be able to go through all of these. We're trying to get through all of them if we can. So the three big ones that I wanted to cover today Log4j vulnerability scanning. Who here has dealt with anything involving Log4j in the past few weeks and months? Hands up. All right, so it's about half of you. So, and the rest of you hopefully have at least heard of it. We'll do a quick little code demo there. Disk cleanup and expansion. Who here has had a server crash, go down, have problems because the disk was full? Nearly everyone, that's what I thought. So that's another really good common example that, that we've built at AMS to automate that process. And then last but not least, also automated end-to-end the process of Inplace Upgrades from Server 2008 R2, which is now end of life, to 2012 R2. So that one we might run out of time with, depending on how quickly we go through this. But I'll go ahead and we will start here. So the Log4j vulnerability at a high level was an exploit found, a remote code execution exploit found in Apache's Log4j logging utility. Not super important what the actual vulnerability is, but it's vulnerable to exploit, and it can allow an attacker to run remote code, which is obviously a terrible, terrible thing that we do not want to have happen on our systems. So one thing that AMS did quickly was turn around a automation to scan systems for potentially vulnerable files. And so I'm going to kind of walk through the high level end-to-end of how that works. So just kind of as a disclaimer, there would just be little snippets of code here, and we're not going to go into huge details of every little bit of code. Not going to go through everything like line by line. It would take way too long, so I'm just going to go through kind of the high level stuff. So we're going to start out with this little snippet here. So then let's see. Let's do it this way. Reading this line, who can take a guess at what this line does? Feel free to just shout it out. No need to raise hands. We're in kind of a small forum here.
Looking for local drives.
Exactly correct. And so the reason to have that not like statement in there is to exclude what?
You don't see drives.
Correct. I found that when you do this get PS drive and you just leave it as is with no conditionals, you end up with local drives and network drives. And we don't want to scan network drives because they're going to be local on another system. So that would be a waste of time, resources, network bandwidth, all sorts of other different things. So that's one little quick snippet that we came up with here. So this little snippet right here will identify exactly as is all local drives on the system. So C drive, D drive, E drive, so on and so forth. So the next bit that we're going to do is take those local drives, and then we'll start setting up an execution of GetChildItem. So hopefully everybody here is familiar with that. That lists items in directories, files, things like that on a local disk. And so just set up a few parameters here. And who here is familiar with splatting? Okay, so for those of you who are not, splatting is a way to store parameter values for a commandlet execution in its own little separate variable. And so when we see the next example here, it should make a little bit more sense. But basically, if you've ever run GetChildItem, you know that it has a parameter called recurse. It has a parameter called file. It has a parameter called error action, which is a common parameter for all PowerShell commandlets. And so what we've done is just broken out those parameters here into this hash table instead of in line when it's executed. And you'll see why we do that here in a moment. So next up, what we do is, this is another kind of little trick that I found through using this, developing this. And so what this does here is this checks the version of PowerShell running on the system. And if the PowerShell version is any version 5.1, then it will prepend a / or // right, to the path. And what that does is enable LongPath support. So what happens is any path longer than I think it's 256 characters in Windows will fail. Will automatically error out unless you use this particular format. So just a little kind of a gotcha. And so what you can see though is that when we did that hash table in the beginning, what we did was we broke out the common parameters. We want to recursively get everything. We want to only get files. We don't care about directories. And then we also want to silently continue in the event of an error. And the reason we want to do that is because we want to not fail when anything happens, which is usually not able to access a file because it's open or something like that. That's usually what happens. And so we don't want the entire thing to come crashing down in the event of a file that throws a particular error. So what we've done here though is we're accessing the hash table. So that's the hash table that we had earlier. But what we're doing is we're adding a different parameter to it. So when you use this crazy little format for the long path, then it has to be literal path is the name of the parameter that you pass to GetChildItem when you use that. When you use just a regular path, you can do it like this. And so all we're doing is taking to get the root value from getPSDrive and passing it in here and here. So it's just a little if-else. If you're running version 5.1, then do this. And so hopefully then this will all make sense once we get to the grand finale here. Next is the actual execution of GetChildItem. And so for those of you who aren't familiar with splatting, this is basically all you really have to do is this little @sign before the name of the variable, and that will pass all those parameters to that call. So that's just a nice way to make things a little bit more readable instead of having these great big long lines that have, dash file, dash recurse, dash error action, dash path, dash all this stuff. Makes it a little bit more easier to read vertically than horizontally, and it also makes it easier, of course, to present. So what we've done is run GetChildItem with the parameters that we specified, and then on all of those, we're going to pipe all of those results to a where object. And we're going to have two different conditions here that if it is successful here. So if the name of the file is this, then we already know that it's potentially vulnerable. If the extension is any of these, then we know that it is potentially vulnerable as well. So probably should have said this a little bit earlier, but please stop me if you guys have any questions, if any of this doesn't make sense, if I'm going too fast or too slow or anything like that. This is a small enough session that we can take a break for any sort of pauses or anything like that. In fact, any questions where we are now?
I think you're doing great.
Thank you. Much appreciated. Then we will skip on to the next. So that slide will get all of the potentially vulnerable files. And then next up is the actual check for vulnerability within the file itself. So what I found here is that when you run a select string on any of those file types that we looked at before, it will actually evaluate either true or false with these different parameters based on whether or not this is contained within the content of that file. So even though you're looking at potentially binary files found that PowerShell, and even just if you open it up in Notepad, it can actually check and see if that class name is present there. And it just will, again, return just a simple true or false. So we've specified the path as we've kind of piped down. The pattern that we look for here, that can be either a regular expression or it can be a plain text expression. So here we've done it just as a plain text expression, and the way we specify that is simple match. So that says don't do regular expression, and that'll make it a lot faster if we're not needing to do regular expression evaluation there. But I think I did forget a little tweak here. There should be an asterisk before and after JNDI lookup.class if you actually do want to use this in the wild here. But we've also done list, which will speed things up a little bit as well. And then again, the error action silently continue in the event that there's any file that's inaccessible or anything like that. And so if you do all of this, it's tough to show all of this in one slide, but you can imagine as we've gone from one slide to the next, how you can pipe from one to the next, to the next, to the next, just with the way that the PowerShell pipeline works. So that works out really well. And so then at the very, very end, then we can just put it together in something like this with just a quick PowerShell custom object. And so in this case, since we're scanning instances, I'm going to just throw the instance ID, and the full name parameter is the full path of the potentially vulnerable file. And so this is not bulletproof. This is not a perfect evaluation of every single possible vulnerability or vulnerable file, but it's a really, really good place to start. And that's what we've really done here, is just produce something quick that customers can run on their infrastructure at scale so that they can determine whether or not that there are instances in their fleet that are potentially vulnerable. So that's what we've done there with the log4j vulnerability. Any questions on that? All right. Then we will jump to the next example here, which is disk cleanup and expansion. So this is going to be another example of splatting here. And first, just a little bit of context, like I talked about earlier in the presentation. Most of you have had a server crash or have problems when the disk gets full. So what AMS has done in part leading up to this is configure the SSM agent to alarm when a disk starts to approach a certain level of utilization. So I don't know what the number is off the top of my head, but once a disk starts to get full, you obviously want to alarm on it before it reaches 100%. Because at that point, it's probably too late and you probably had issues already. So then what we want to do here, though, is when that happens, we want to kick off this automation that does a couple things. One, that attempts to clean up a disk to free space on it. So what we discovered is that you can actually free up a fairly good amount of space on a disk just by running some built-in Windows tools like disk cleanup and using DISM as well. So so some tricks first here is that disk cleanup is not installed by default on Windows Server. And so I have a little bit of magic that runs before this to copy the source files for disk cleanup from the installation media store that's local on every Windows installation there. That one is relatively straightforward to do and find. The code is a little bit too long to show here, but the next step, of course, is to then specify the parameters that disk cleanup is going to run in. Who here has run disk cleanup manually? That's everyone in the room. I love it. So you run it, you see it. There's a full list of a bunch of different options, and you can check which ones you want, right? And so the trick is to automate that to automatically clear all of those. I found that in my testing, there was no need to exclude any of those categories, and so there was no danger to that. It just empties the recycle bin, clears some temporary files, and different things like that. So what this little snippet does here is it sets up a splat for registry values to automatically check every box that disk cleanup can clean. And so it does it in this nice little one line, and the real trick is that asterisk. So any subkey in this location will have all of this set up here, and then the actual registry item will get created that way. So, and then also the force true will overwrite any existing values. So if there's any existing configuration where somebody's run this cleanup before and they've checked some boxes and not others, we overwrite that to make sure that everything possible gets cleaned up there. So that's how we handle that. Any questions on that?
What are you doing with the null equals there?
So the null equals is to suppress the output of new item property since we don't need it. In a perfect world, really what you would do is you would set that value to a variable and then check to make sure that the registry items got created the way that you want. But kind of outside the scope of this to show that really, but yes, so that's what it is, just suppressing the output. And in my testing, the best way to suppress output is setting null equal to the value. If you've ever done anything where you're suppressing it to where you're piping it to out null,
Right.
apparently at scale, null equals is a little bit more performant.
That's exactly what I was asking, why you use that.
In 5.1, it's been fixed and set.
Gotcha. Okay, then that's a fantastic point. So so I was not aware of that. So yeah, and again, unless you're running it,
If it's gonna set 9% path, it's still gonna be 5.1.
Exactly.
So that's the best way to do it.
and yeah, 99% of the time for these, you're still running 5.1, and even if you're not, you have to approach a pretty massive scale to be able to do it. But trying to just follow the best practices as I know them. That's awesome. I did not know that was fixed in PowerShell 7 because I'm using that for my personal development most of the time unless I do 5.1. So, but we still have to be mindful of compatibility with 5.1. So hence, of course, the previous example where we're enabling GetLongPath support for 5.1. So no, great question. And that's exactly why I do that the way that I do. Again, perfect world with best practices, you would want to validate that the registry keys got created the way that you wanted, and maybe alarm or error if they didn't. Because then your whole, everything will be misconfigured, or disk cleanup might not even run correctly. So after that then, this is the part where you kind of run everything that we've just done there. So we do a quick start process call to the path where the clean MGR, the disk cleanup executable is, and we pass some different arguments to it. And it's a little unintuitive the way that this works, but the argument list will specify that disk cleanup look in the registry and follow what we just created in the previous step. So that's all that really does there. And so it doesn't have to, you don't have to pass any other parameters to it, it just uses it from there. It's the best way that I found to do it. There wasn't really any way to do it in the parameters of the start process call there. And then the next kind of trick here is this wait process step. So what I found is that disk cleanup, the executable, will run, and then it will finish, and the cleanup process will not actually be done yet until the DISM host executable is done as well. So wait process is pretty straightforward. It just finds an executable with that name and waits until that process is finished. And if you pass multiple, then it will wait until all of those processes are finished. So when I was developing this, I found some scenarios where clean MGR would be finished, where disk cleanup would think it's complete, and that executable would no longer be running, but there was still cleanup going on in the background. And we didn't want to have anything going on until that process was totally complete. And then after that, the next step, I don't know if anybody has ever run this. You've probably run the old school DISM version of this, where you can kind of imagine what the parameters are of DISM. I forget what they are off the top of my head. This is the PowerShell commandlet version. It's exactly the same if you've ever run DISM /online/ cleanup image and all of those different types of commands there. So it's exactly the same, just the PowerShell commandlet version in native PowerShell, which is whenever possible, use that whenever you can. And then finally, we've waited for DISM and DISM host to complete as well to make sure that those processes are complete before we go ahead and do anything else. So that, and then following that, then we reevaluate whether or not the disk has come below the free space threshold or the disk usage threshold that we have. If it has, then our job is done. If not, then we kick off some more automation that is mostly outside of PowerShell to expand the EBS volume that the instance is running on, and then we expand it within the file system of the operating system as well. So outside of what we're talking about here, I don't have that code to show you, but you can kind of imagine what it is. It's relatively straightforward. Systems Manager orchestrates a lot of it with expanding the EBS volume and different things like that. If you've ever done that in the AWS console, it's exactly the same thing. You just do it through Systems Manager instead. Be happy to talk more about that. I'd like if anybody wants to chat after the session too. But and then we go into I think it's a resize - partition is what makes the call within the operating system to actually expand the partition itself. Any questions on that disk cleanup and expansion?
Just that what you were just mentioning, so after the AWS part is done, you do have to run some PowerShell to actually get the OS to utilize that space?
Correct, yes. Correct, yes. And so that's what happens. So there's the AWS side, and then there's the OS side. The OS does not recognize when there's more space available. You actually have to, if you've ever done it in, in any sort of VM or anything where you go into disk management and then you rescan and then you expand it, just basically the PowerShell version of that is what we do on that AMS side to make sure that the operating system sees and recognizes and expands the file system to that. And of course, there's lots of other checks in place as well. Do a lot of prerequisite checks to make sure everything is set correctly. Like we found problems with the defrag service running, so we wanted to make sure to temporarily disable that. And some other different things like that to make sure that we don't expand it beyond 2 terabytes because that, if it's a boot volume, so then it wouldn't be able to boot from that if it was expanded beyond 2 terabytes. Different things like that. But yeah, the biggest one is to do the resize partition call after the orchestration completes the expansion of the volume. Does that answer your question? All right. So then, any other questions on that?
Are you just triggering these through SSL run commands, or how are you running?
Yes. So it's all orchestrated through a series of systems manager automation documents. You can, if you've ever used run command, very, very similar, where it's just a step-by-step process defined in a JSON or YAML document. And so this orchestration really just kind of bounces back and forth between the AWS API calls, the volume expansion, different things like that. And then it will jump back to a run command to execute the PowerShell. So the AWS-run PowerShell script document is what really runs, orchestrates this PowerShell, but the rest of it is just an automation document. Any other questions? All right, then it looks like we will indeed have time for the final example. So this actually might be my favorite. This is why popular demand, perhaps from one of the AWS folks in the audience that I worked with closely to make this a reality. This was a direct customer request, actually, to be able to in-place upgrade end-of-life Server 2008 R2 instances. And I'm sure, well, you know what, let's do a show of hands. Who has had to upgrade some end-of-life operating systems or deal with in some way end-of-life Windows OSs? Okay, so nearly everyone. So this should hit home pretty well with a lot of folks here. And so then, so you guys can see where this is coming from. This was a customer ask, and of course, the first call out here is best practice is not to do this. Microsoft and AWS both advise against in-place upgrades. There are a lot of different reasons for this. Any of you who have ever done them probably have run into one or more of them in the past. But that was a conversation that we had with this particular customer, and they did not have a viable alternative, and too many instances to deal with in too short of a time frame, and wanted to upgrade them in place to get them to a supported state, and then deal with migrations or other alternatives after that. So this is the standard "don't try this at home" warning, the skull and crossbones. But it was still a really cool project to work on, and something that AWS offers as kind of a fairly manual process, but within AMS we went and we did a full end-to-end automation of that. So kind of walk through this step by step here. It's going to be a little wordy. I don't have quite as much code to demo for this one, unfortunately, because it is a little bit longer. So you can kind of imagine what a lot of this is, though. And so as Microsoft documents, A, don't do this. B, if you're going to do this, there's a lot of prerequisites that you need to follow, and they're not very well documented. It's in a lot of different locations, and so over a lot of trial and error and a lot of hours spent researching, found some pretty solid prerequisites to test. And if an instance meets all these prerequisites, then we can go ahead and try to perform the upgrade. So first, do we have enough free disk space? And that's a big one, because the Inplace upgrade takes a lot more disk space during its process than it actually needs in the end. And so what I discovered is it needs probably about 30 gigs of free space on the disk to start. If you don't have that, then as we kind of discussed in the previous example, we can automatically expand that volume. So we actually built on some of the automation that we developed in the previous example to automatically expand the root volume of the operating system to be able to accommodate that, so that we don't just fail and have that error out. So instead we automatically expand that and then proceed with the rest of the prerequisite checks. After that, PowerShell version. So that's pretty important because of some of the specific commandlets that we run as a part of this. And I believe that the version needs to be 5.1, but I would have to double check that in the actual code. But it's basically, we can't do it on PowerShell 2. If anybody's ever tried to write code that targets PowerShell 2, it's a very painful process. I would not recommend it. It involves a lot of .NET and just a lot of herring and different things like that. And so what I decided was to go ahead and error out if a PowerShell version is 2.0. And at that point then, we recommend that either our operations team or the customer upgrade the PowerShell version on the instance. And then after that, next up is what version of Windows is it running? So in this case, we were targeting Server 2008 R2. That's pretty straightforward. We just run a quick WMI call to see what version of Windows is running on there. And we check that against a version that we have in a predefined supported list. And it's something that we could potentially expand on in the future, but right now we're just targeting Server 2008 R2. Next up would be edition. So are we talking standard, enterprise, data center, web, the million different SKUs that Microsoft has? And the interesting thing is that they map in very interesting ways between in-place upgrades. So if you're talking about going from 2008 R2 to 2012 R2, those additions do not match up perfectly. So you have to find some pretty interesting mappings to do. It's very annoying, but once you have it figured out, it's quite nice actually. And so installation type is next. And installation type in this case, all we're looking for is server. We just want to make sure that it's not a workstation. We want to make sure that it's not running the desktop version of the operating system, because there are versions that will report back as the same equivalent as 2008 R2, which I believe would be Windows 7 in the background there. So you could do that, but checking that version is the most reliable way that I've found. And then next up, install roles. So I don't know if anybody has ever had a Windows Inplace upgrade fail because of installed roles, but there are certain ones that if you have them, what was the one? WSUS, okay, there you go. I haven't had WSUS fail for it specifically, but I've had a dependency of WSUS, IIS, cause it to fail. So IIS is one that I check for in this installed roles. The really annoying part is Microsoft does not document this anywhere. The only way to find this out is to try it and fail. So that was pretty frustrating, but after some trial and error on some customer examples, thankfully the customer was kind enough to duplicate some instances and provide them to me as examples to help with the development of this. So this was really fantastic and a super useful data point. Because most of the time you're testing with fresh instances. You're testing with fresh blank VMs, from an Amazon provided image, and so it doesn't have any of those things on it that a customer would have from years of tech debt, from years of operating server, and different things like that. So the installed roles was really helpful. That's still a work in progress. If we discover more roles that block upgrades, we can add them to the code really easily. It's just a nice simple array in PowerShell, and that's all there is to that really. And then another really fun one, Windows activation status. If anybody's ever tried to upgrade an unactivated Windows installation, it does not work. And so that can be a very curious thing, because you might not know a Windows installation is not activated for a long time. That's something that can go 6 months without detection or longer if you don't have any sort of alarming or alerting or monitoring on that. So that was a really fun one to discover and add, especially with some customer examples that could not reach the KMS server and different things like that. So the next step after all those prerequisites are complete and they pass is we build an answer file, also known as an unattended file. Who here is familiar with that? Okay, so most of you. So if you've ever built one before, you know it's XML based and it's not the most trivial thing to build in the world, but once you have a decent formula in place, then you can actually do that. So what I've done in my PowerShell is actually included the content of it in a here string. Is anybody familiar with that? Show of hands if you ever used a here string in PowerShell. Okay, so just a few. Basically all that is just a multi-line variable in PowerShell. So instead of just however long your one line can be, it actually allows it to be multiple lines, the same way that an XML document would be multiple lines. It just makes it really, really easy to do that. So what I did there was substitute in the values that I need in the answer file, write them to the disk of the OS, and then after that, start the upgrade. And then the easiest part was to wait for the upgrade to complete. The interesting thing is that there's not really a good way to do that, to find out when the upgrade is complete. And what I actually found is the best way to do that was to check and see what version of the OS is being reported by the SSM agent. And so once that actually registers as server 2012 R2, then the upgrade is complete, and that's all there is to that. So that is how I just have, in particular in the automation document, a step to wait until that condition is met. And then that's the end of that process there. And then once that is complete, then we consider the upgrade to be done. And the instance is on 2012 R2 and ready to go. And I think I have accidentally duplicated my slides there. But, all right. Any questions on any of that? That is the last bit of tech that I have. So we're open for questions here for the next few minutes.
Have you done any work bringing the server instance to 2022?
I have not, no. One thing that I can say is that there are some automations available on the AWS consumer side, outside of AMS, that orchestrates that to some degree, but I have not done any work on that myself.
It seems to run a bit better.
The Inplace Upgrades?
Well, yes.
Okay.
Depending, like I've done some test migrations with hosts actually running 2012 R2, bringing them up to 2022. Things like IIS all seems to upgrade in place just fine.
Okay, gotcha. All right, so then Microsoft may have done some work there to make that a little bit smoother of a process over the years, so that's really awesome. That's good to hear. Well, then it might make my job easier the next time the cycle comes around with 2012 R2 to 2016. So we'll see. Hopefully the same problem doesn't come through, but I'm guessing that it probably will. Any other questions?
What did you do about those roles? So didn't any of the customers have roles? Like you said IIS, like to me that's, in my experience, that's one of the things people want to migrate because they're running some website or something.
So what we do is we basically inform the customer of that and then try and work with them to figure out what the best path forward is, because
It's impossible if you have IIS, you can't do it.
correct. It just blocks, it stops. And then there's a Microsoft compatibility something or other that report that gets generated, and then it'll just say can't upgrade or anything like that. So
That's only 2009 R2 to 2012, that's not 2012 R2 to 2016, I think that's fixed.
I don't know. That's a good question. I would have to try it myself. I don't know. Because I think really the big problem is that it's not only an OS upgrade, but it's an IIS version upgrade, because there's different IIS versions for different OS versions, and they never match up, and it's tough enough to get an OS upgrade in place to work, much less the rest of it with all that. So, yeah. Any other questions?
What do you use to work in AWS and places and rather than test these things? Because sometimes that can be.
Okay, so that's a really great question. And so what my team has done is we've developed a testing framework that we use internally to basically provision CloudFormation templates and test the results of the automation documents against the results that we expect. That's the shortest possible version that I can give of that. But yeah, we've developed something custom internal to do that. But in short, it takes provided CloudFormation templates, provisions those, and then executes the automation document against that infrastructure, and then tests the output of the result. And that's hopefully what we expect. That's our version of integration testing internally.
And you pull logs, like design the system log, and tell it how much, or
For that, no, we just test the results of the automation documents. If we need the results of anything else, we use the SSM agent to get that and output that as a part of the automation. So everything is done on the scale of the automation itself.
inside, for sure.
Correct.